Hi everyone, it's Mrs. Griffin with the Unit 2 Lesson 9 video number 2. So number 4 on page 32 we did in class together, and here is the proof. If you did miss any part of it, you can pause it now and copy it down. But there is another way we can prove something is a rectangle. If you remember, we discussed different things that can be true, and some of you were asking about proving that a rectangle is a parallelogram with congruent diagonals. If you do wish to do that, I have that written out too. When I'm done, you can pause it. So you can prove it's a parallelogram just like we did before. That's not going to be different. That's the same as up top. And then you can prove your diagonals are congruent using either the distance formula like I did here or Pythag. And you do the diagonals, AC and BD, and you show that those are equal to the same radical. And then you can tell me that AC and BD are the same, they're congruent, they have the same distance. And then because that's true, a rectangle is a parallelogram with congruent diagonals, and so it would be a rectangle. So pause it here if you'd like to copy this version down as well. We are going on to number 5. To talk about a rhombus. So, a quadrilateral is a rhombus if. Now, there's many things that people will think about when it comes to rhombus. So, if you go into the back and you look at your rhombus page, I have 3 ways shown here. Now, remember I told you get to pick the one you like best. So it depends on your preferences on which one you choose. Some people will only remember that a rhombus is something that has 4 sides the same. And so you, if you were that person, would do your Pythagorean theorem or the distance formula to show that all the sides would be the same distance. And then you could tell me that congruent segments have equal distances, show me they're all the same, and then make it a rhombus that way. Some people prefer to do it that way. You also can prove it's a parallelogram using the way we already showed, and then show that 2 sides next to each other are congruent, making it a parallelogram with consecutive sides congruent in a rhombus. Or you can prove that it is a parallelogram using the way we usually showed, and then show the diagonals are perpendicular. Again, it's totally up to you which way you prefer. I like to do the slopes. A lot of my students like to do the distances, so I am going to show you both of those. So I'm going to show both. I recommend you listen and pick the one you like and pause it so that you can write down everything afterwards. So the first one we're going to do is if all sides are congruent. This is not my preference because I do not like sitting here doing a lot of Pythag, but again, a lot of my students prefer that. So if I wanted to do that, then I need to figure out the distance for all 4 sides. So I'm going to do PQ first. So to get from P to Q, my Pythagorean theorem, 1, 2, 3. This is 4 units and this is 2 units. So 4 squared plus 2 squared equals C squared. And PQ is radical 20. And then the next one I would do is QR, which is also 2 and 4. So since it's the same, I can reuse this work for QR. And then I'm seeing that they are all 2 and 4. So I can reuse this Pythag work for all 4 of them. And then I can say that congruent segments have equal distances. I'm just going to change this up here so it's not just PQ, it's all of them. And then I'll be able to say that PQ, QR, RS, and QS are all congruent segments. And then a rhombus is a quadrilateral with all sides congruent. Since I have all sides congruent, PQRS is a rhombus. Pause it if you want to copy this one down. Since I prefer slope, I prefer to do that if it is a parallelogram with perpendicular diagonals. And then I'm just doing slopes. So I would do the slope for PQ and the slope for SR since they're across from each other. From P to Q, it's up 2 and right 2, 3, 4. And from S to R, it's also up 2 and right 4. Both of those simplify to 1/2, and they're equal. So just like all of the other ones, parallel lines have equal slopes, means that these are actually parallel. And I can write PQ is parallel to SR. And then for the other pair of opposite sides, I'm going to do PS and RQ. 1, 2, 3, 4, 5. Nope. Up 4 and right 2, which is 2 over 1. And 1, 2, 3, 4, right 2, which is also 2 over 1. Notice they're not negative reciprocals, that's why those aren't right angles. But now I'm also getting that PS is parallel to RQ, which means that it's a parallelogram because parallelograms have both pairs of opposite sides parallel. Okay. Then I would go, okay, I need my perpendicular diagonals. So I'm going to find the slopes for the diagonals. So PR is one of the diagonals, and SQ is the other one. So from P to R, it's up 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 6 over 6, which simplifies to 1 over 1. For SQ, it's down 2 and right 2. Since I went down, it's negative. And this is negative 1 over 1. And what happens here is these are negative reciprocal slopes. And so now I know that PR is perpendicular to SQ. Putting these concepts together, I can say a rhombus is a parallelogram with perpendicular diagonals. And so since I have a parallelogram with perpendicular diagonals, PQRS is a rhombus. If you prefer this version, please pause here and you can write this one down. Lastly, we're going to talk square. So square is kind of everything. You have to prove all of it. So you're going to totally pick whatever you prefer. So a quadrilateral is a square if, and there's going to be a lot here. Most people will pick that all sides are congruent. But it also has to have a right angle. Okay, this is what most people will pick, so this is the way I'm going to do it. So all sides are congruent means I'm using distance, and the right angle means I'm using slope so that I can get that perpendicular. So because of that, you're going to do your 4 distances. If you do choose a different way, I will show it at the end. You can pause there. So for my distances, I'm going to start with AB. 1, 2, 3. This is 3 and 4, so I know that has to be 5 because of a 3, 4, 5 Pythag triple. So because of that, I know the distance for AB is 5. 1, 2, 3, 1, 2, 3, 4. And I'm getting lucky because BC is also 5. 1, 2, 3, 1, 2, 3, 4. So is CD. And so is AD. So that triple made my life a lot easier. So now, because of the equal distances, congruent segments have equal distances, I know all four of these sides are congruent. BC, AB, CD, and AD. All right. Now I also need to show that it has a right angle. So I'm going to pick two of the sides. I'll pick AB that are next to each other and BC and show, I'm going to do slope because I have to show the right angle, which is perpendicular. So from A to B, it's up 3 and right 4. Remember, the signs matter. Up and right are both positive. From B to C, it's down 4 and then right 3. You have to do rise over run, and you have to watch your signs. So down 4, right 3. All right, these are negative reciprocals. So perpendicular lines have negative reciprocal slopes. And I therefore know that AB is perpendicular to BC, which means perpendicular lines form right angles, that where they meet, which they share the letter B, they meet at angle B, is a right angle. It's 90 degrees. So now if I have all sides the same and a right angle, it's a square. And I have right angle here and all sides congruent here, which means that ABCD is a square. Okay, if you do go to the back, you can pause here if you need to, and you look at square, you can see you would be able to do this also by using only slopes and only distances if you prefer. So if you do prefer that, you can show that you have all four right angles by doing all the negative reciprocal slopes. And I showed that method. Or all the distances because your diagonals would be congruent and all the sides would be congruent. I'm not going to show that version. So if you do prefer, if you do prefer to do the slopes only version, you'll do all the slopes and you'll see that you've got all sorts of negative reciprocals. So because of that, we're going to have a bunch of perpendiculars. AB is perpendicular to BC, etc. All four sides here plus the diagonals. The perpendicular lines form right angles will give us the angles that A, B, C, and D are all 90. And we have the perpendicular diagonals. And so you can get your square that way. Your choice. All right, see you in class.